All right, cool. We are up. Um, all right, so nice job on PA4. Lots of good designs and implementations. Um, and PA4 is a good kind of bash exercise because in a lot of cases you probably found your script wasn't necessarily a lot of lines of code, but those lines are doing some pretty powerful things. Particularly compared to if you tried to write a C program with that few lines. Um, it's very hard to make graphical pop-ups and work with calendars and dates and all this sort of stuff. And so the tools we have available in Bash, things like grep and sed and awk and dialogue, right, um, can work, really to our advantage if you know how to use them, right? And you got to be able to sort of think about these things, get familiar with them, work with them on the command line, see what they can do, and then use that to try to solve whatever problem you're trying to solve. And so PA5 is going to be sort of more of the same. We're not going to mess around with dialogue. PA5 is going to be a really straightforward utility to use. It's going to read from standard in, it's going to write to standard out, and that's all it's going to do. Um, but to implement PA5 as a bash script, you're going to use a lot of the powerful tools that are available in bash, not only sed and awk and grep and so on, but also some of the lower level abilities in bash to make arrays and to make in particular what are called associative arrays. And so let's do this as follows. Let me take you through the posted PA5 assignment, and we'll do kind of a quick first read through that, and then we'll talk about the sort of two or three main pieces of PA5, and we'll break those down into some main sub pieces, and then we'll start digging into some of the mechanics that are available in Bash, a deeper exploration of sed and such, and also looking at arrays in Bash. So let me.
Bash again?
It's gonna be in Bash, yeah.
Aw.
I used to go pretty heavy on C in this course because I wanted to get people ready for 222, but 224 is really supposed to be about Linux tools, and so it's really where you're supposed to kind of get the essential background for working in Linux. So yeah, so we're gonna go with Bash here, but I'll do some more ODPs in C, probably later this week or next week. All right, so PA5. So PA5 is a script that will basically read an input file containing text and will pull out what we call phrases. So, for example, a phrase would be for your final CSE224 programming assignment. That's a phrase. You will implement a bash script named main which reads from standard in. That's a phrase. Breaks the input line into phrases. That's a phrase. Records how many times each phrase occurs. That's a phrase. And after reading all input, that's a phrase. Prints out a list of all phrases along with tally of how many times each phrase occurred. That's a phrase. So there's several phrases in this paragraph, right? And a phrase is basically what you would think of. It's a little kind of standalone sentence piece. A lot of this document is explaining exactly what makes a phrase, right? So we'll dig into that along the way. But for first order, just think of a phrase as something separated by punctuation from some other part of a sentence. All right, and the goal of this program is you run it, it reads from standard in, it looks at the input, it breaks it into phrases, and it remembers how many times each phrase has occurred in the input. All right, and then at the end of reading the input, it prints out a table of how many times each phrase occurred. Okay, pretty simple kind of core functionality, but a lot of details in how to implement it. So your script is called main, and if I say something like this is a test, this is a test, hello, this is a test, hello, goodbye, and I'm hitting Control D for end of line. So it says I saw the phrase goodbye once, I saw hello twice, I saw this is a test 3 times. And if I say hello, this is a test, how are you? Like that, right? So good is a phrase, and hello is a phrase that appeared twice, and how are you appeared twice, and this is a test appeared once. All right, got the basic idea?
Does the assignment constitute what a phrase is?
Yeah, that's what the bulk of this document is going to describe exactly what this means. But just for a first order sort of back of the napkin understanding, right, this is what a phrase is. It's a thing separated by punctuation from other phrases. All right, but all of this is going to go into details of what makes up a phrase. All right, so essential requirements. Program has to run on the Linux server. That's where I'm going to test it. It has to be a bash script. You can use sed, awk, tr, which we'll talk about. It's a translate program. And all the stuff that comes with bash. If statements, while loops, arithmetic operators, arrays, associative arrays, and so on. Okay. You should definitely test your code on your own, sample input. But there's also a series of test files available. So if you go onto the Linux server and go under temp PA5, you'll find a series of test files, test 0 through test4.in. And I've recorded what your program should produce in test 0 through 4.out. So for example, test 0.in looks like this. And test 0.out, which is what your program should produce, is this. So as you're writing your code, right, you can be testing it on your own files, but when you're trying to pin down the details of what exactly is a phrase, what do I do with these characters, and so on, you can go to these test files and confirm that your code works exactly the way it's supposed to.
All right, where exactly did you say this was?
So /temp/PA5.
Okay, thank you.
Yeah. And so test 0.in is basically, some uppercase, lowercase, and a bit of punctuation. Test 1.in is a little more punctuation. Test 2.in is a lot of weird punctuation, which we're mostly going to ignore. Test 3.in is a really strange file, right? And so these are increasingly difficult tests. And then test 4.in is a long file of 2,000 lines. So that makes sure your code isn't blowing up. So there's 5 tests you can work with. All right, very specific rules about how to handle input, how to break things into phrases, and so on. We'll talk about those. You read from standard in, write to standard out. No other output is allowed, right? Don't print out any prompts to the user. Don't say, hello, welcome to my program. Don't say, your input had 5 lines or anything like that. Just read standard in, produce to standard out. So if you say main, hello, bye, it should just print out 2 lines of output. 2 phrases with a tally next to each. All right, we'll come back to input cleansing and extracting phrases and building the tally in a minute. We'll come back to post-processing, testing. So if you use these test files, right, my suggestion is run them into your main program, take the output, do a sort-n. That output should be character for character exactly the same as the test file in, this is wrong, /temp/PA5. But you want to sort it -n because that's what I did to the output file. So this will let you compare the files character for character. And this is part of how I'm going to grade your program. I'm going to run your program, I'm going to feed the input from a test file, I'm going to pipe it into sort-n, and I'm going to compare that to test 0 through 4 dot out. All right. This goes in a subdirectory under your repo called PA5. The main script has to be called main. If you have any other scripts that you're calling in support of that, make sure those are in the same directory. And then grading, to get any points for the assignment, it's got to be written in Bash. It's got to be available on Git. It's got to run on the Linux server. It's got to work on general input, not just these 5 test cases. It should read from standard in, write to standard out. Should not generate any errors that cause it to exit abnormally. And then assuming it does all of those things, you get points as follows. If you call it main, you get 5 points. That's an easy 5 points, right? Just call it main. If it reads input and produces some sort of output, you get another 15 points. If it's a cow telling me a joke, you still get 15 points, right? So produce some kind of output at least from your input. If the format of the output is correct, meaning, you know, it's a number followed by a space followed by the phrase, that's 5 points. If there's no extraneous output, you get 10 points. And then each of these first 3 tests are worth 10 points each. Sorry, first 4 tests are worth 10 points each. The 5th test is worth 5, right? That's a fairly aggressive test to pass because that's a huge file. In the beginning of your main script, the bash script called main, after the shebang, you need to have your name, a date, a description of the project in your own words at the top of the script. Okay, that's 10 points. If any of that's missing, you lose 10. And then your code itself has to be formatted in some consistent way. It has to be commented. You have to tell me what each section of code is doing, comment the lines that are not crystal clear what they're doing, and so on and so forth. That's worth 10 points. All right, and then some ideas on how to succeed with this assignment, right? The first one being start early. So this is due a week from Friday. Okay, that's the Friday after Thanksgiving. If you don't want to work on Thanksgiving, make the deadline Wednesday before Thanksgiving, right? So you've got well over a week. You've got a week and a half from today, and we'll start going through some of the aspects of Bash today that you need to do this. But the deadline's that Friday after Thanksgiving. So start early, right? If this seems like a walk in the park, just go ahead and do it and get it out of the way. If it seems really complex, start it now, right? It's not going to be, 25 levels of nested loops and scripts calling other scripts, passing back values and all this kind of stuff. The flow of the program's going to be pretty straightforward. It's going to be, basically from top to bottom with maybe one loop inside and a few if statements, right? The whole challenge is figuring out what you're going to do in those few statements, right? So as an example, you can do this in 23 lines of Bash, right? And this is a lot of function going on here, but we're going to use some really powerful tools in Bash. So it's more about figuring out what you're going to do and how you're going to do it, as opposed to just starting to write, a few hundred lines of if statements and assignment statements and so on. So we'll go back and we'll look at what it means to cleanse your input, look at a phrase, break things into phrases, tally, and so on. And I'm going to suggest you just work on this in pieces, right? The input cleansing and breaking into phrases is the most detail-oriented piece of the whole project. And that's kind of a standalone task. You can do that without worrying about, counting up the number of times each phrase occurs, formatting your output, all that kind of stuff, right? It's kind of a separate task on its own. And you can break that into 2 tasks. The first is cleansing, and the first is breaking your cleansed input into phrases. So there's a lot of ways to chunk this down into sub-problems, and that's really what I'm hoping people will spend most of their time on, is taking the big problems, figuring out how to break them into smaller problems, and keep doing that until, solving this small problem is, 2 lines of Bash. And solving that problem is 3 lines of Bash, right? And so you put these things together.
Is this something we have to discover, or will it be taught?
It's going to be taught, but you're going to have to play around with it to figure out how to use it in the best way. But right after this, there's some sample code that's going to help you a lot. So right, this is going to take multiple tries. There may be some missteps when you start and find out this isn't a productive path, right? So you got to start this early, right? Don't try to start this, a few days before the deadline. It's not going to work. Use the command line to try things. Don't force yourself to make a big long script and keep running through the whole script every time you want to test, something in the last line. Get comfortable running things from the command line, right? Go into Bash, and where you've got your Bash prompt, you can type any Bash command in there that you want. If you're not sure how to create an associative array, don't try to do it in a script where you're tallying phrases. Just, write some statements on the command line. All right, and definitely ask questions. If you don't know how to start, come by office hours tomorrow and we'll talk about it, right? Once you've got the input broken into phrases, then you can start working about how to save these in an array and how to tally them. And you can do that on the command line too. And so here's some sample code, and we're going to work through all of this together in class. Today or tomorrow we'll start going through some of this, but this is stuff that will help you, right? Maybe not verbatim, but you're going to have things similar to this in your program. But we're going to have to talk about what an associative array is and how you use it and so on and so forth. And this is not a group project, so back to working alone. Although very few people took advantage of the group aspect on PA4, I was kind of surprised. All right, so cleansing your input. So there's two main things going on in here. So PA5. So two main tasks that you're doing. So break input into phrases, and then tally the phrases. By tally, I mean, make a tally of them. Here's this phrase, I've seen it 1, 2, 3, 4 times. Here's that phrase, I've seen it 1, 2 times. Here's another phrase, I've seen that 7 times, right? So there's taking your input and breaking it into these phrases, and then there's counting how many times each phrase has appeared. That's what I mean by tally the phrases. And then, there's printing the results. So showing this to the user. So let's just talk about breaking your input into phrases. And there's going to be basically 2 steps to this. Step 1 is to clean the input. So we're going to condition it so that the input looks like something that's easy for us to process. And cleaning the input is going to mean converting everything to uppercase, getting rid of certain characters, dealing with spaces, things like that. And then 2 is breaking the input into pieces, which are what the phrases are. So we're just looking at these 2 steps for this first part of PA5. All right. So input cleansing. So here's the way that you want to cleanse your input. And if you wiggle around this and try to do other things, it may work, it may not work, but this will work. First thing, convert all your letters to uppercase, and there's a command called TR that we're going to go over, which makes this one line in Bash. In fact, I'll show you right now. If I say TR, quote, A through Z, quote, upper A through upper Z, this is the TR command. This reads standard in, converts to uppercase, sends it to standard out. All right. You don't have to do any work to make this happen. There's a command built in for this already. It's called TR. Just say TR, A through Z, and it converts anything in this range to stuff in this range. If you have something that doesn't have letters, it leaves it alone. If you have something with lowercase letters in the middle, it converts them to uppercase. All right, so that's the first part of cleansing your input. Convert everything to uppercase, all the letters to uppercase. And it's one line. Just use TR, transliterate. All right, we're going to remove special characters. So parentheses, brackets, curly brackets, quotes, double quotes, at signs. We're going to remove all of those. And there's a pretty easy way to do that. So for example, I could say TR.
Does TR mean transform?
I think it's transliterate or something, but yeah, basically transform, translate. So let's say I wanted to remove all the vowels from my input. I could say let's translate A, E, I, O, U to an at character. All right, and I've changed all of my vowels to this character. And if I take this and I pipe it into sed, and I change my at character to be nothing, right, now I've got, you know, a one-line bash command that removes vowels from my input. So using tr and sed together, we can do something really, really powerful, right? And in C, you know, you've done some ODPs where you removed X's from your input, and that took a bunch of code, right? And here I can specify multiple characters that I want to remove, and I'm just using a little trick, right? I'm taking all those characters, I'm changing them to a single symbol, and then I'm saying, let's just get rid of that symbol everywhere on our line by using sed. So we're going to use some trick like that to basically remove all these characters from the input line. So when we're looking at your input text, we're not going to do anything with parentheses, brackets, quotation marks, at signs. We're just going to get rid of them. All right. We're also going to take multiple spaces and turn them into a single space. So if there's, you know, hello with 5 spaces there, we want to change that to just hello space there. And we can do that with sed also. So if we do sed space, quote, substitute slash, space space star, we'll dig into this in a little bit. But this says look for a space followed by 0 or more spaces and replace that with a single space. Right, so that changes all my spaces to just a single space. And then what you're going to do is, instead of changing those things into a space, change them into an underscore. And so now I've got my input phrase kind of cleaned up. I've dealt with multiple spaces and I've changed them to underscores. And now we're going to take certain punctuation marks, like these, and change them into spaces. So if I do this and I pipe it into TR and I say, let's change all of these things into a space, right? What have I done? I've made a phrase. This is a test, followed by a space, followed by hello, followed by a space, followed by bye. So these are going to be my phrases. Right? With the exception that the spaces in my phrase are actually turned into underscores. But now I have a set of phrases separated by spaces. And in Bash, if I have a string of characters separated by spaces, I can iterate through those characters one at a time using a for loop. Okay, using a for statement. And so here's a version of a for phrase, a for loop that you're allowed to use in Bash now, which is for something in something else. So let's
Real quick.
yeah.
Does the period and the space, that's the indication of the end and the beginning of a phrase?
Yeah, so periods, commas, semicolon, colon, those things separate one phrase from another.
Okay, cool.
All right, so let's see. So here's an interesting for loop. This is called a for in. So for data in, and here's a string containing some spaces, do. And let's just echo what data is equal to. Done. Oh, that's not what I wanted to do. So for data in, and here's a phrase containing spaces, do, each time I go through this loop, data, this variable, will be set equal to the next piece of this space-separated string. So it loops 4 times and says this is a test. So let's try this in some code. Alright, so I'm going to read a line of text from the user, and then I'm going to do this for loop, and it says for word in $text. And what this is going to do is it's going to go through whatever the person typed in here, one word at a time, right? Where a word is something separated from other things by a space. And it's going to find the first word, it's going to set this variable equal to that, and I'm just going to echo what that word is. And then it's going to go on to the next word, and so on and so forth. So if I do that, hello, this is a test, goodbye, it loops through that loop 6 times. Right, and each time this variable word is given the value of the next word separated by spaces from the input. So if we're doing all of this stuff that we did up here, to take your input and turn it into a series of phrases separated by spaces, we can now extract those phrases one phrase at a time by using this for loop. Alright, that's your first part of PA5. It's taking the input and doing these kinds of things. Right, doing some TRs, doing some SEDs, and so on and so forth, to build a space-separated set of phrases and then go through a for loop. And my suggestion is, for phrase in $phrases, where this is the thing containing your cleaned up input line, do, and do whatever you want to do with phrase in here. Right? What you want to do with phrase is add it to a running tally. Alright, but your first part is, just put an echo statement in here, echo $phrase, and make sure that you're breaking up your input correctly. And when you're done, right, it's when you're done and it's working perfectly, it's, a half dozen lines of bash. But that doesn't mean it's simple, right? It's you've got to understand what these tools are doing, and you've got to figure out how to put them together to make all of this happen. But if you follow these guidelines and you look at what we've just done in class, you can probably get this going in an hour or two from the command line. There's details, right? If you're using TR and you're trying to change a single quote into something else, you can't put that single quote inside double quotes. You might have to escape it with a backslash. So there's details, right? But you want to try to work up to the finished product, right? So start by doing things interactively on the command line and get a feel for what these commands are doing. And then, if you're trying to change a single quote into an ampersand, this isn't going to work because it's going to get all confused. But that's not going to work. That's not going to work. Right, but that's going to work. So I can use double quotes to change a single quote into something, but I can't put a double quote inside a double quote. But I know about pipes. And I could do something like this. I could say, let's translate a single quote into an at symbol. And let's take the result of that and run that into TR. And translate a double quote into an at symbol. Alright, and now I've got both single and double quotes being changed the way I want. So those kinds of things aren't spelled out in here, right? Those are things you need to figure out. Well, you don't need to figure that one out because they just showed you. But that you need to figure out and think about, right? And that's the part of when I talk about getting your hands dirty and working on the command line and messing around with this, right? It's trying things like this. All right, so that's the first part of PA5 is cleaning your input, right? Converting things to uppercase, getting rid of special characters, and then breaking it into phrases. And my suggestion for breaking it into phrases is take the things that separate phrases, turn those into spaces. And before you do that, take the things that actually are spaces, change them into underscores, so you remember that those are spaces. But if there's a period or a comma or an exclamation mark, something that ends or begins a phrase, change that into a space. And now your input looks like, here's phrase 1, here's a space, here's phrase 2, here's a space, here's phrase 3, here's a space, and so on. And these phrases, this is a fun class. The spaces in there would be changed into underscores so that the only spaces are separating one phrase from another. All right, and then once you have space separated phrases, use a for in loop to loop through, and in this case, this loop would go through 3 times. The first time phrase would be equal to this, and then this, and then this. All right, so that pulls out your phrases, and like I say, you can test that by just, echoing the phrase here with some delimiters maybe, and make sure that it's parsing and processing the input correctly. Then you want to build your tally. All right, and building the tally, this is where we get into associative arrays. So associative arrays are part of most languages. C has a package for them. Java has classes for them. Bash has them built in the structure of an array. And the idea of an associative array is the following. A traditional array, so let's just think C. Let's say we say integer x bracket 10. So we're saying, hey, x is going to store more than one value. It's going to store multiple values. And we're going to call those values x bracket 0, x bracket 1, all the way up through x bracket 9. So we get a bunch of values under this single variable name x. And the index, the thing that we use to request a particular element in this array, is an integer. And the integer is bigger than or equal to 0 and less than or equal to 9 in this case, because we said it's got 10 elements. So that's a plain old traditional array. An associative array is exactly the same concept, except your index can be something other than integers between 0 and 9. Alright, let me say that again. An associative array is like a traditional array, except your index can be more than just an integer between 0 and 9. I could do x bracket 100. I could do x bracket -5. I could do x bracket 2.718. I could do x bracket hello. I could do x bracket Nick, comma space, hello, comma space, bye, exclamation mark. With an associative array, your index can be pretty much anything.
So this is like basically an object in other languages, right?
This is like a dictionary.
This is like a
Right,
dictionary, yeah. It could be an object if we were in an object-oriented language, but it's more specifically something like a dictionary. This is also known as a hash. And this is a kind of weird concept to, yeah, or hash map, someone said in chat, or a map in Java. So this is a different way of thinking about data, right? We have an array of, you know, maybe integers, for example, in this case, but we can index it with different stuff, including really strange indices, including indices that aren't even numbers, but are strings, you know, collections of characters, or maybe binary data. And why would we want to do such a crazy thing? Why would we want to index an array with something other than the numbers 0 through 9? If you're just trying to store a bunch of test scores so that you can calculate the average, right, this works great. If I wanted to store a bunch of test scores associated with each student, I could have an array indexed by each student's name. I could have, you know, scores bracket Nick, scores bracket Izad, scores bracket Carol, and in that element of the array I could store, you know, the score they got on their test. And now if I want to know what Izad's score was, it's just scores bracket Izad. And this may seem like just kind of something quirky, but once you start digging into this, this becomes like a really powerful sledgehammer, right? So when I first encountered associative arrays when I was an undergrad, this became like my do everything tool. And for like a year afterwards, every problem I had in computer science, I solved with an associative array. It was just my go-to, you know, hammer. And it's, in some theories, the way that our minds store information, right? We don't have an array of facts and memories in our brains that we, you know, if we want to remember somebody's name, we don't start with our first memory and go to our second and our third and march through until, you know, we get to year 25 where we met this person and learned their name. Our memory is much more complex. It's a series of cross connections. And you know, you see something on TV and you suddenly remember somebody that you like were hanging out with when you saw something similar on TV. There's all these associations, and so there's a lot of cognitive theories that our memories in our minds actually work through something like an associative memory like this. All right, so what can we do with this? What can we do with this for tallying phrases? We can make an associative array. Let's just think of it as called tally. And if we see a phrase like hello, we can store something at the index hello. We can store the number 1, saying, hey, I've seen the phrase hello once. And when we see a phrase that says this is fun, we can store at the index called this is fun. We can set that equal to 1 and say, hey, we've seen this phrase one time also. Now, if we keep reading input and we see the word hello again, the phrase hello, we can check our tally and say, oh, we've already seen this phrase once. Okay, I'm going to increment this and record the fact that I've seen hello twice. And now I get the phrase cool, and so I record tally bracket cool to be 1, and now I see the word hello again, and I say, oh, I've got a hello already. I'll change this from a 2 to a 3. And then I see the phrase, this is fun, and I say, oh, I've seen that once, so I'll change this to a 2. And we're building up this count of how many times each phrase appears. So that's what we're going to do with associative arrays. So we'll finish up PA4 presentations tomorrow, and then we'll start working with some of this code for creating associative arrays and putting things into them and getting things out. And we'll just be playing on the command line tomorrow, writing some statements like this. But the goal of this is to be able to take our phrases, use them as indices into a tally array, and store our counts of how many times each phrase appears. Alright, I got a few typos in here to correct, so I'll be reposting this after classes today. But other than that, that's basically PA5. So we'll continue with that tomorrow. Have a good afternoon. See you next time.
Okay, bye.
Bye.
See ya.
Have a good day.
Alright, you too.
Have a good day.
Thanks.